Okay, everyone, rather than give you a paper copy, I was going to talk you through the Unit 9B review. So, for this first question here, consider the following reaction. A gas plus B gas produces C solid plus D gas plus energy. And notice we have a double arrow to represent that this reaction could reach an equilibrium. Now, describe everything that would happen if D was added. So here's what we got to do. When we talk about adding something to an equilibrium, it means we're going to be following that Le Chatelier principle. And this would say that to minimize the stress, this reaction, this equilibrium, would do the opposite if D was added, if we're at equilibrium. So what is the opposite of add D? Let's start out and write down that the opposite of add D is remove D. Now, if you want to remove something from an equilibrium, you got to go away from it, not towards it. So that means this reaction would shift to the left. So it would shift left. And now let's think about what would happen. So first off, if we are shifting left, the amounts of A and B, really the pressures of them or the concentrations, A and B would go up. Now if you're going this direction to the left, that means the amounts of C and D would go down. Even though C is a solid, it's not going to change the equilibrium, but it will be used up and still go down to the left. Now let's think about pressure. We're going from 1 mole of gas to 2 moles of gas. Now if we remember that moles of gas cause pressure, that means the pressure would also go up because we're going from 1 mole of gas to 2 moles of gas. And then finally, since we're going away from the energy, I want you to think about the fire again. And if you're going towards energy, think about walking towards a fire. Things will probably get warmer. And then if you're going away from energy, think about walking away from a fire, and that means the temperature would probably go down as energy is being used up. So I would say all of this stuff would be happening after D was added. Start out with doing the opposite, and then think about the effects. Okay, let's go and look at some more Le Chatelier questions. How will this reaction here shift? So we have a gas with a gas with a gas with a gas, all good here. What happens if carbon dioxide is removed? The opposite of removed is added, so this would shift towards the CO2 to the right. B, water vapor is added. The opposite of added is removed. If you want to remove something, you go away from it. So you would go to the right away from the H2O. Okay, the pressure is increased. Once we see the word pressure, we need to count moles of gas. Now there's 2 moles of gas on this side, and there's 2 moles of gas on this side. So this would be a big, no shift question. Pressure's increased, no shift. Volume is increased. Now, technically it's not going to do anything for the same reason as this one, but let's always, when we see the word volume, I want you to think about how volume relates to pressure. So volume and pressure have an inverse relationship. So if volume is going up, pressure would be going down. And then we have to apply the opposite. If pressure goes down, the equilibrium would want to try and increase pressure, but the moles of gas were equal, so this would have no shift to the equilibrium. Okay, question 3. We have 2 moles of gas. Looks like it's an endothermic reaction here. Energy is on the left side. We have gas and gas, or 2 moles of gas and 1 mole of gas. Okay. So questions. What would happen to the equilibrium if oxygen gas is removed? Well, the opposite of removed is added, and if you want to add something, you go towards it. So this would shift right. The pressure is reduced. I see the word pressure, I count moles of gas. There's 2 moles of gas on this side. There's 3 moles of gas on this side. Now, the opposite of reduced would be we want to increase pressure. If you want to increase pressure, you would go towards the greater moles of gas. Okay, C, the temperature is increased. The opposite of temperature is increased is temperature is decreased. If you want to decrease temperature, you go away from the energy. So again, we're going to shift right. And then lastly, sulfur dioxide is added. Let's read carefully dioxide. There's also a trioxide in there. The opposite of added is removed. If you want to remove something, you go away from it. So then it would shift left. Okay, question 4. How will the reaction shift in order to reach a new equilibrium for this reaction? So we have a gas turning into a solid in a gas. Now right away, I like when I kind of inspect these reactions, I get rid of these solids. Delta H is negative. We need to remember from Unit 8 that a negative delta H means it is exothermic and that energy would be found on the product side. Again, I like to kind of throw this in there right away so they can use it to analyze problems. So what happens if we add CO2 to the equilibrium? Well, the opposite of add to CO2 is remove CO2, so it will shift to the left. What happens if we add carbon solid? Solids do not affect equilibria, so that would have no effect, no shift. What happens if we increase the temperature? The opposite of increased temperature is decreased temperature. That means we want to go away from that heat. Adding a catalyst. I mentioned in the notes that the catalyst will speed up a reaction, but it speeds up the forward rate and the reverse rate. So this has a no shift effect here, or no effect. What happens if we increase the pressure? The opposite of increased pressure is decreased pressure. If you want to decrease the pressure, you got to go to fewer moles of gas. We have 2 moles of gas on the left. We have 1 mole of gas on the right. So if you want to decrease pressure, we would go to the right towards the 1 mole of gas. For F, what's the opposite of remove CO? Add CO. If you want to add something, we go towards it, to the left. Okay, I hope this gave us enough practice over all the Le Chatelier type problem expectations. Now down here, draw a graph of time versus concentration. So time versus concentration. For the following reaction, if you start with equal amounts of reactants, so we have A and B, and no product. So that means the initial amount of AB would be 0, and the initial amounts of A and B would be equal. So we could say there's like a line there. And no product, and the K value is greater than 1. So the K, what's going to happen then is these reactants will start turning into product. So they would go down, A and, oops, I should say A, comma B. So they would go down, and the products would go up. Now, what happens to this line if it says K is greater than 1? If K is greater than 1, that means the concentration of products has to be greater than the concentration of reactants at equilibrium. So I guess this line would overlap this line, and then they would reach an equilibrium. So something like that would be my initial graph. Again, we started AB at 0 because it said no product. A and B would start anywhere up here. Now if you only have these, the concentration would have to go down. This concentration would then go up. And because the K value is greater than 1, the AB would overtake the A comma B. So this is the A comma B line. They would be the same, I suppose, or they could end up at somewhere different. And this would be the product. Okay, now it says, now add to the graph if AB was instantly added. So if something were instantly added, I would say at this time, maybe like the star time that would represent this, instantly added would means it would go up like that. Just in an instant it was added. Now let's think about Le Chatelier and what would happen. If I add AB to an equilibrium, that means it would shift left to remove AB. Now let's think about what happens. This is going back to the first problem. If it shifts left, the concentrations in A and B would then go up a little bit. Oops. Go back here. AB was, this was added. So that means these two would go up a little bit. And then if we're shifting left, the AB concentration, the product concentration, would go down a little bit. It doesn't really matter how much these are going again. And then I would just draw a new equilibrium. So again, why did this go up? Because it said AB was instantly added, and it would just be a straight up line. No slope there. And then we need to apply the Le Chatelier principle to say that if AB is added, the opposite of is AB is removed, so it would shift left. And if it shifts left, the concentrations of A gas and B gas would both go up, and then AB would slowly go down until a new equilibrium was established. So I'll make another video for the backside, and I hope this is getting us starting to master the Le Chatelier principle.